Good afternoon, Mr. Marlowe again. We're going to do a lesson on proportions and solving a proportion. We're going to start with the foundation of it, and then we will explain how to find a missing number in a proportion, and then we'll just talk about the shortcut. Should be pretty brief. A proportion is when you have two fractions or ratios that are equal, okay? And we know that 3/4 is equal to 6/8 because you can either say, I can reduce 6/8 to 3/4 by dividing 6 and 8 by 2. 6 divided by 2 is 3, 8 divided by 2 is 4. So we know they're equal. Other way we can do it is to say that we know that 3 times 2 is 6 and 4 times 2 is 8. And if you multiply the top and the bottom of a fraction by the same number, you get an equal fraction, okay? So we've established that those two are equal. What we're going to do now is do something called the cross product. And the cross product is what happens when you multiply diagonally across the equal sign, okay? Remember, I use the star symbol as my multiplication symbol. So I'm going to multiply the numerator of one fraction by the denominator of the other. Same thing this way. And 3 times 8 is 24. 4 times 6 is 24. All right? We'll leave that for a second. Let's look at this one. Same thing. These two fractions are equal. If I multiply top and bottom of the fraction here by 6, 2 times 6 is 12, 3 times 6 is 18, we get equal fractions. But if I do the cross product, once again, numerator times denominator, and then the other direction, 2 times 18 is 36, and 3 times 12 is 36. What do we notice here? Well, we notice that when I have two equal fractions and I multiply the cross product, I get the same number for each cross product, 24 here and 24 there. It also happens over here, okay? When I multiply this diagonal, I got 36. When I multiply the other one, I got 36. And that is going to be true for any proportion. Anytime you have two fractions that are equal, if you multiply the diagonal of each fraction, you will get the same number each time. It's called the cross product, and they're going to be equal. And that seems kind of neat, but it's really useful if you're in a situation where you know that two fractions are equal, but you're missing one of the numerator or the denominator in either of the fractions. And you may be like, well, how's that going to help? Well, we know that they're equal. How do we know that? It tells us. We're told that whatever this number is, number of fourths, is equal to 21/28. Okay? Based on what we just did over here, where we multiplied diagonally and got the same number, I can do it this way. If I multiply C times 28, that's just 28 times C. But I know it's going to be equal to whatever this is, 4 times 21. Okay? Well, I don't really know what 28 times C is for sure, but now I do know that it's going to be equal to 84. Because 4, and you know, you calculate, use your calculator, don't hesitate. 4 times 21 is 84. So now this is what I have. I know that 28 times some number is going to equal 84. How can I figure out what that number is? Well, division is the inverse of multiplication. So all I got to do to figure out what C is do 84 divided by 28. That will tell me what number I multiply 28 by to get 84. So 84 divided by 28 is 3. So that means that 3/4 is equal to 21/28. And if I come up here and I put a 3 in for that C, I realize that if I multiply 3 and 4, both of them by 7, I get 21/28. So, this is what I call the formal process. But let's go back real quick and talk about what did we actually do to get my answer for C. Well, what I did was I did 4 times 21. And then what did I do? I divided by 28. And I got my answer of 3. The way I have my students remember this is I tell them to multiply the diagonal that's complete, the one that's got both numbers in it, and then divide by the one you didn't use. In my class, I expect my students to write this part down on their paper because that's what I call the proof. Shows that they do know how to get that answer. All right? So I got 3 more examples. We're going to do them quickly. And why do I have 3 examples, you might be wondering? Well, how many locations are there in a proportion? There are 4. Top left, bottom left, top right, bottom right. So there's 4 places that could be missing a number. It doesn't matter which one's missing. You do it the same way, but I just thought I'd give a brief example of each one. So, here we go. I want to know what C is. And by the way, these could be any variables. I want to know what C is. So, here are my 2 diagonals. Which diagonal has both numbers in it? The 7 and the 15. So I multiply my diagonal that is complete, 7 times 15, and then I divide by the number I didn't use. I haven't used the 10 yet, so I'm going to divide by 10. Okay? And again, don't want to make any mistakes. I've done the hard part. 7 times 15, divide that by 10, and that is 10.5. And again, in my class, that is required as the proof. But Mr. Marlowe, 10.5, that's a decimal. These are fractions. Well, not really. They're really ratios. And a ratio is just comparing 2 numbers, and it is entirely okay for us to have a decimal in there. Okay? And so there you go. So very simple. And again, just to prove a point, what if I made this an A right there? Who cares? It's a variable. We're missing a number. Well, once again, here are my 2 diagonals. A is going to be equal to, well, which diagonal is complete? 60 and 30. So I multiply those 2 numbers together. 60 times 30. What number haven't I used yet? 20. I'm going to divide by 20. About to run out of room, so I just come down here and say A equals, and I take my calculator, because once again, why make a careless mistake now? 60 times 30, divide that by 20, and I get 90. And if I'm not in a hurry, go back and just see, 60 and 90, and what do I divide 60 by to get 20? If I divide 90 by that same number, do I get 30? Yes. All right, and the last one, last location, I want to know what C equals. Once again, which diagonal is complete? It's got the 5 and the 8. So I do 5 times 8. What number haven't I used? The 2. And again, it's late. I don't want to make a careless mistake. So I have to redo the video if I did that. Okay, 5 times 8 is 40. Divide that by 2. C has to be 20. All right. One thing I want to say before we close the lesson is when I say which diagonal is complete, I'm not talking about the fraction that's complete. Remember, I'm saying which cross product going across this way is complete. So that's the only thing you really got to be careful about. is make sure you are looking at the diagonal and not at the fraction when you think to yourself, multiply the complete diagonal and then divide by the number you haven't used. Okay, I hope that was helpful. Again, this is Mr. Marlowe. Appreciate you watching, and good luck.